Hello, everyone. First of all, I really thanks for joining my presentation. This is Hwang from Samsung Research. Today, I'd like to talk about how make your code secure. Actually, I will introduce our automated security analysis tool and system. I believe it would be helpful for you to manage your code securely because it makes the security quality of our software enhanced. Now I'm working for a security team at Samsung Research and leading security lab 1. Our team consists of two labs, lab 1 and lab 2. Our lab takes in charge of security assessment, including vulnerability analysis and penetration testing on our product. So here, I hope to share our experience. Before introducing our approach, I'd like to talk about the current software development trend. These days, software size is really huge. For instance, software platform like Android and Windows and service platform like Facebook have 10 million lines of code. And especially, the high-end car system has more than 100 billion lines of code. And if you get any smart device, we will use this device over at least 3 years, even though smartphone. So it means we need to handle the huge software for a long time to provide a secure experience to user using your software. Second trend is open source software. These days, so many companies and developers already adopt open source and contribute their software to open source community. Internet and IoT, the mobile application, already use more than 70% the open source software. Our company also actively contribute and adopt open source software. Our company also use our developed software also consists of more than 70% open source software. So a long time ago, we just adopt software platform like Linux and Android. And then we started to contribute more software like Tizen and IoTivity. These days, we are trying to contribute more things for future technology, 5G, AI, and robot. Software size is really huge, and then open source is actively adopted. In such environment, what we are facing in security aspect. There are so many vulnerabilities are reported, and the number of reported vulnerability is quickly increased. For example, the last year, more than 16,000 vulnerabilities were reported in public, and then the half of them happened in open source software. These are famous vulnerabilities like Heartbleed, Ghost, Meltdown, Spectre. This has the name and icon and reported number. And then you can easily check this give directly effect to the company financially. In such an environment, we have the software size become more and more huge, and then we actively adopt the open source developed with external developers. And then the number of reported vulnerability and quickly increase. In such environment, we have to handle our software securely. So how to manage our software securely is the main theme of my presentation. My presentation consists of two main parts. One is automated security analysis tool and security management system. First, I'll introduce the analysis tool and system. We call our system Automated Vulnerability Analysis System, AVAS. AVAS has three main functions. One is known vulnerability scanner. Actually, to detect known vulnerability like CVE. Another feature is a Credential Scanner to detect credential information embedded to your software. Last thing is automated fuzzer to analyze potential vulnerability in our software. To support them, we closely connected to developers' development system and then collect a lot of data from the various sources, like a development site, open source community, and also vulnerability DB. So we collect this data and then analyze them. We make the DB to detect and analyze our software. When we make some automated system, the most important thing is to make developer think this system is very helpful for them. In my experience, if it make burden to developer or provide high false positive, it never use the automated system, it don't trust it. So we focus on the several requirements. So we try to make the fully automation and provide low positive, actually the high accuracy. And then we provide the patch information. The developer can easily patch and fix the bug in their source code. So first, I will introduce the known vulnerability scanner, actually CVE scanner. So I first introduce what is CVE. I think the audience already well know about the CVE, but some people might be unfamiliar with the CVE. So I shortly introduce the CVE. CVE is short for Common Vulnerability and Exposures. Actually, publicly reported vulnerability in our software. National vulnerability database called MVD store and manage this CVE list with additional information like fixed information and severity score and impact rating and so on. Our system also collects this CVE list from the MVD. This is actually the detect and fix flow for CVE in manual. Most cases, the developer summarize the open source list they are using. And then they search CVE list in MVD site. To search CVE list in MVD and then find how to get their patched information about their detected CVE. And then they have to decide they fix it in their open source version or they have to change it with the latest version. Most cases, the latest version already applied the patched code. But the human, every developer to support them, we need a lot of resource. And then every developer have to summarize their open source and search and collect patch information. Additionally, this floor has some pain point. The first, when we summarize the open source identification, it is not easy to identify all of open source. Some developer will know which open source he is using, but some developer a little bit confusing or they make some mistake. Even though they are using which open source, sometimes they didn't know exact the version. And then they have to also search the CVE list in MVD. if each developer to try to search the CV list, maybe they not get the correct patch information. And then they list up the open source. Most developers like different style the name. Because of that, they cannot correct the CV information. And then even though they find correct patch information, they have to decide, and then the floor also makes some mistake. If a developer tries to get patch information, it is not easy work. The MVD just provide how to get the fixed information, not provide the correct patch information. The developer visit the developer site or open source community and then find the correct information. So many cases, they cannot get the correct information and they just modify they want. And then when we change our software with the latest version, it also has some problem. Sometimes the developer modify the open source state he is using, and then sometimes the open source changes the API or function or parameter. So we cannot apply this way. Actually, there are several open source detection solution, commercial solution and open source solution. But they cannot, most algorithms just based on detect from open source name and version. So their solutions has high prosperity because many CV exist in various versions and code should be modified to fix them. And then when we did the algorithm analysis, our code cannot cover the modified version or mixed vulnerability in our code. So our algorithm try to analyze line-based matching. So first, we collect all patch information. Our algorithm also based on the MVD. So we first collect CV list from MVD. We automatically collect all of information. And then we collect patch information from different sites. So we make some DB with correct patch information and CV list with open source name and version. From the CV information, patch information, we extract the valuable information. When we look at the patch information, removed lines are related to the vulnerable code, and added lines are related to the patched information. So we extract this information and then make vulnerable sequence and patched sequence. Actually, it is a high level, the floor. Actually, we use some detailed filter and parameters. Given targeted code, we compare. Targeted code is more closer to which the sequence. And then we decide it is patched or not. In this case, we decide this code is patched. So we provide the vulnerable code information to developer. So actually, we given some targeted source code. We use two algorithms. Actually, our algorithm has low perspective, the high accuracy, but sometimes we are difficult to decide because the similarity is similarity is difficult to distinguish. So we cannot deliver exactly. To cover this, actually false negative, we use also CV list based on open source name and version. So given the targeted source code, we first identify name and version, and then we use our algorithm. And then also we are parallelly use the CV list of open source name and version, and then we matching it. As I introduced you, our algorithm has low false positive and high accuracy. So if our algorithm decided this code is patched, we give this code is secure. And if our algorithm decided this is the vulnerable, then we give you have to patch this vulnerability. And then sometimes we cannot decide from our algorithm. To cover this the pain point, we also look at the CVB list and then give our result. You have to, the red means you have to patch. The green means you already patched this CVE. And yellow color means you need to look at this code. It is vulnerable or not. And then we provide more information. So just the developer upload their software, we identify each the open source and then analyze that the open source has which type of the vulnerability. And then also we provide detailed information. So developer, we provide how to fix those vulnerability. So we automatically collect all of the information and then automatically analyze the developer's code. So developers don't search their CVE and analyze their code and collect patch information, something like that. We just correct guide with the vulnerability information. Second tool is Credential Scanner. Credential Scanner is also a very important tool. Many developers hard code credential information to their source code because of several reasons. I think in my opinion, though, one main reason is actually for their convenience. They just embed the access token API key to their code. They can easily code and use external API and server. So they put the API key or token. And then many users also put the password ID. Another reason, many developers are unfamiliar with the security consideration. So they don't know how to hide their information, and they don't interested to hide some information. Anyway, it looks like a simple mistake, but it makes the critical problem. You can easily imagine what happened. Malicious user, if malicious user can get your access the key or secret key, they can access to your secret information, and also if they can have access key to your code, they can erase your code and encrypt your code, and then require the money or Bitcoin, like a code ransomware. And another risk is we can inject malicious code to your repository and your software, and then wait until this software is widely propagated, and then he can do something with malicious code. So credential is embedded to the software is very, very the critical problem. So we analyze our software to find the credential information. First, we filtering the file, the keyword and pattern based. So we select the file. We decided candidate to search, and then passing all of line, and then we analyze the pattern and keyword at whitelist with regular expression. I will I will show the example in the next page. And then we give our result, which credential is detected in which line of your code. Then developer can easily hide the information and remove the credential information in their code. This is example. First example is the Amazon access token. The line use some keyword, secret key, access ID, secret key, something like that, and then they have the fixed random string. And AWS, in case of AWS, the access ID had prefixed character, AKIA, and then 16-byte the string. So we can check by regular expression, this is Amazon token. And then this case also, they have some credential information like email address and password, ID, something like that. So we can also check this is the credential information. So those are mechanisms we can detect the API key, token, password, cryptographic key, something like that. Last, our tool is the automated fuzzing. The fuzzing is an automated software testing technique to find security-related bugs. We provide invalid, uninspected, or random input to computer program until program is crashed. To find unrevealed bug, they should be able to travel many paths as possible as they can go. And in this call graph, to find the bug, they should be the branch with the security-related bug. It means they have to penetrate each condition and then generate input to make the memory leak, like a buffer overflow. So generating input is very, very important in fuzzing system. So this picture is example for graphic processing program. Graphic processing program generally receive the input like a common photo and picture. But to test this the software, we give some random and unexpected input like this. And then sometimes it is the break because of the unexpected input. Actually, even though we are to assess our device, we can always meet the unknown vulnerability or zero-day vulnerability. Always happen. And then we have a lot of software and device and also connected, all device connected. So how much efficiently to fix and find unknown vulnerability is very important. So why do we need to automated fuzzing system? I'd like to recall the graph I explained in the front page. For a couple of years, the number of reported vulnerability is quickly increased. Why did it happen? I think reporter and other outsider analysts also use the automated analysis system like a fuzzing. So it depends on the development of security analysis techniques. So we need to do analysis more efficiently and effectively in compared with outside researcher. And then when the human our team just makes some all fuzzing code, it is really burden because we have a lot of software and the module and device. So the number of the fuzzer depends on the number of package and API and parameters. So to do that, we have so many fuzzers by manual. So actually, our main concern is not to develop core algorithm for fuzzer, even though we are researching the fuzzing algorithm. Our main concern is to concern is how to build fully automated fuzzing system. But fortunately, I mentioned the input is very important in the fuzzing system. Fortunately, we already have very important advantage. In case of our company, to release software or apply software to our device, all developers write up the unit test code to cover more than 90% line of code. So it means we can already traverse over 90% of our software. So we use this unit test case code. And then developer just put their code, we automatically generate the fuzzing code, fuzzing library, and then run that code to the server side. So developers don't need to do something for fuzzing. This is the overall flow of our automated fuzzing system. Given unit test case and library, we are analyze a program. And then based on the unit test case, we decided which function and parameter we have to use. So we automatically generate the fuzzing the library and then test in the cloud side and then to the report to the developer. We also give the result with detailed information, which input make the crash, and then which memory is problem and which code area is problem. This is the overall system for ABAS. The developer actually don't do anything to analyze any security-related bug. Just we do something automatically and then report to the developers. When the developer commit their code to the repository, we analyze their code automatically and then give them report. And then we periodically analyze our stored code, even though after releasing software. The reason why new vulnerability continuously detected and collected, so we need to scan again with the new vulnerability and newly edit the code. So continuously working this system. So we run this system more than 2 years in our company. So we find the unique CVE, or large number of the unique CVE, and then we really detect the many number of unique credentials. When we designed the credential scanner, we just test with the public repository. At the time, we was really surprised. There are so many credential information in public repository. So you can easily test the similar things in public side. The next thing is the management system for security the weakness. We call it SSMS, Samsung Security Management System. Actually, even though we provide a strong automated security analysis system, we cannot cover all type of the vulnerability or security weakness. So we need to review and remove security risk for the initial phase. To handle this, we operate and we design the SSMS. SSMS is to actually support security development lifecycle, called SDL or SSDLC. We define security activities for each development phase to remove potential security weakness from architecture and design phase to production phase. So we do many activities like architecture review, design review, threat modeling, some secure implementation guide, the security testing, something like that. And then after releasing our software in production, we also monitor our new vulnerability and the exploit related to our device. But it is actually depend on the personal skill of security engineer. We cannot keep the same security level for our software. So we want to high and the same security level for our device and software. Because of that, we make the system to manage our software for full product life cycle. Actually, we record everything, security activities and result, and analyze it. Also, it used to improve our security activities. Actually, our system actually tightly coupled with other development system. So, by using SSMS, developer and security engineer are communicating with each other and develop and review and security and their source code, all of things. This is a screenshot of the system. You can check them. We already defined all of activities for each phase, and then we do together with developers. At the time, also, they have to test with the ABAS. Okay, a little bit early, we'll finish it. So anyway, so far, I introduced our own automated analysis, security analysis tools and security management system. So the managing your code securely is the best way to implement clean code without any security weakness. But I think it is impossible in Europe because, as I mentioned, software size is really huge, and we actively adopt open source software developed by the outside developer. So we have to consider always my software and our software is developed by other developers. And then reported the vulnerabilities and quickly increase. And then the analysis, also security analysis tool is quickly developed, so we have to handle all of things. To do that, we provide the automated analysis tool and try to detect various types of security weakness with high accuracy. And then another important thing is consistent management. We always want to provide high-level security and the same level of security for our product. And then you can also try to similar things from our experience. There are so many open source solutions to do similar things. So from our experience, I think I can help you make and build and manage your software more securely. Thanks for listening to my presentation. Do you have any question and comment? Okay.
I'm just curious, what platforms have you tested this for?
What platform?
Yeah.
I tested which platform means? I just tested the Tizen and all of software in our company. Okay. Yeah. Other comment? Okay.
Hi. Does the use of fuzzing, I can see where it can identify a lot of code bugs.
Yeah.
But how much security issues does fuzzing identify? What sort of security issues does that identify?
I think the software is crashed by fuzzing. In my opinion, it's my opinion. We have to patch the bug. I think most of the security-related bug detected by the fuzzing. Fuzzer just report the crash information, and then sometimes the program, the hang. The hang is not security-related bug. The most case is crash. The crash is, I think, security-related bug. Sometimes the crash is not important because it is not doesn't happen the serious problem. Anyway, it is bug, and then later it can also use like a security analysis. So I think we have to patch most of things.
Hi, it's Luke Desitels from the Knox security team at SRA. I'm hoping we can speak some more offline after the talk.
Yeah.
But I did have a quick question. Can you describe the differences between the Samsung tools used in Avast and some of the open source ones that you've recommended? For example,
right.
But are there certain Samsung specific things
that
help?
I can tell you. So for the fuzzing, we can also use the AFL and Repurger, the open source fuzzer. And then also we are using our own the fuzzer. And then open source scanner, and then the Credential Scanner, we use our own the algorithm. Actually, Credential Scanner, I think it's little better than open source algorithm because we also investigate the open source. So we added some customize and edit the algorithm. And then for the CV scanner, our algorithm is, we think, much better than open source the scanner. Yeah. Is there other questions? Okay.
Kevin O'Neill, Cyber Research. Do you utilize outside pen testers, security organizations?
Actually, our team don't use outside hackers because we have some great hacker. So, yeah, our team already have some hacker. So top hackers. Some people, some achieve some great award in DEFCON, CTF, or something like that. So, and then I'm working for Samsung Research, but business group, actually production group, sometimes use outside the company for consulting. But I'm not sure, Also, they ask our team to assess the product and service, so we support them. Yeah.
Well, the other one is commercial products like Fortify, such as the military uses them on several contracts.
Yeah.
Would they require a vendor who's coming into the contract to use the same tool suite?
Yeah. Our company or compare?
I'm just saying as an observation on some military programs, they're comfortable with certain vendors of security testing tools.
Yeah.
They have large contracts and say, okay, you're going to come into our environment, so we want to make sure you get the same tools.
Yeah. Actually, there are a lot of tools to analyze the software. Our company already using the commercial tool, but so especially static analysis tool is a little bit the overlap of our system, but we just focus on security bug. So other static analysis tools just to find the bug, general bug in the source code or software. So they cannot detect those detailed information about the security. So we cannot compare all of the solutions. So we just compare the famous solution, some of famous solution and open source. Okay, thanks for listening to my presentation. Thank you.